Okay, welcome everyone. This is my name is Martin Beracuchea, and I work as a software developer in the microbiome informatics team. I work in the MGnify resource, and today we are going to discuss the MGnify API and accessing microbiome data computationally. So let's begin. So the learning objective for today is to understand how to interact with the MGnify API, how you can actually use it, and learn how to actually write Python script to programmatically access the data that we have on our MGnify REST API. I would like to start with a few words on what MGnify is. So basically, MGnify is a free resource for the assembly, analysis, and archiving of microbiome data. We provide an automated pipeline for users to submit their own data, so we can their own microbiome data, and we can analyze that data. We provide then taxonomic profiling of that data, and we also provide functional annotations using a bunch of different tools for users to explore. And we also run analysis on public data that is stored in the European Nucleotide Archive. So at the moment, we have analyzed over nearly 300,000 samples of using our automated pipelines. So there's quite a lot of information for you to explore, and I really encourage everyone to go to our website and explore it. You can go to ebi.ac.uk/metagenomic. That is our homepage. From there, you will get a bunch of information, a bunch of tools for you to use. But this webinar is mostly focused on our API, so I think it's really important to set the definition of what an API is. Maybe not everyone on the webinar is aware of that. So basically, a web API or application programming interface is basically a tool for users to access data that is available on a web resource. You can think of it as basically the sockets in your house that you basically plug things to those sockets, and those tools can actually use the electricity to whatever function, whatever they need that. So basically, if you use the correct libraries or tools to connect to that API or that socket, you can use the data for whatever you want. So basically, using our web API, it's possible to explore and consume the MGnify data. And this allows you to explore the data, to run extensive or personalized analysis on your own data that has been analyzed with our pipeline, or the data that we have there that is public, basically. So you can do whatever you want basically with it, and I consider this to be a really powerful thing. So basically, most of the APIs that I know of are basically used for data exchange or data mining. And regarding the visualizations that you can build, I have some examples on these slides. So for example, on the top right corner, you have a taxonomic analysis of the different biomes that we have on our API. We are plotting basically the relative abundance of each phylum there. So across all the different biomes, this is one of the things that you can do. You can also, for example, using the metadata of each one of these studies that we have there, you can use the geographic location of those projects there or studies, and try to use a map to locate those things, or for example, explore one phylum there and see the geographic location of it across all the different studies that we have. Or you, for example, can use the functional annotations to run correlation studies, or I don't know. There's really endless possibilities, and the data is all there and is freely available to everyone. So if we talk specifically about the MGnify API, I would say the first two things that you need to know is the base URL, or the web direction, as most people call it. That is ebi.ac.uk/metagenomics/API. This is going to be the homepage. If you are working with the API, on this page, you will find all the different endpoints that we have, all the information, and we also have the links to the documentation. We also provide extensive documentation for each one of the collections that we have on the API. So you can go and browse that using your web browser. That is really useful. And some of the things that I consider to be the strengths of our API are basically that we are an hypermedia-driven API. That means that we try to provide links, auto-generated links to each and every one of the entities that we have. For example, if you are browsing one collection, the samples collection, we're going to provide the links to each one of the entities that is connected to that sample. For example, the analysis of that sample or the biomes that are related to that sample. So you don't have to build that by yourself. This is really useful. We also follow a specification how the data is actually structured. Basically, our API main data format is JSON, and JSON is a text format that is widely used in the industry for web APIs, and it's basically a really compact and human-readable way of sending data from one endpoint, from one party to the next. But we also, even though we provide JSON files for each one of the endpoints, we also format those JSONs following the JSON API specification. So each one of our collection has the same structure. So you know what to expect from all the collections are going to have the same structure. So you need to, if you know how to work with one of them, then you already know how to work with everything. That actually allows us to use some of tools. For example, JSON API provide implementations of how to interact with APIs. So basically, you can actually install a library for your language, for example, for Python or for R or for Go or for Java, for example. And then using that, you can actually consume the API much more easily than actually doing the HTTP request by yourself. And we also use a schema using the Open API specification, and this allows us to build our documentation based on basically on the source code of the API. This is what I was mentioning. You have a link to the documentation on this slide, and if you go to that Open API documentation, you can explore all the different endpoints, how to interact with those endpoints, and actually what to expect from those endpoints. So I really recommend, if you are starting to work with our API, I strongly recommend you to go to this web page at EBI/metagenomics/API/doc. You will find a link on our web page. So when you get to our website, this is the homepage of MGnify. And on the header menu there, you have a link to the API. So if you click there, you will end up in the API browser. This is the homepage for the API. You will get all the different endpoints that we have, all the different collections that we provide access to. For example, if you can see the biomes here, I'm going to zoom this. You can access the biomes, for example, all the different studies, samples, runs. There's plenty for you to explore here. I'm going to go through one of the endpoints and see how everything is structured. As an example, let's go, for example, to the studies endpoint. Okay. This is all the public studies that we have on our DB. This is a collection of all the different studies that we have there. So first, let's explore the different components of the web page. This is, as I mentioned, this is a collection, so it's a huge collection. It has 164 pages. So we have a pagination tool here for you to go through all the different pages in an easy way. We also provide a filter section, so you can actually filter the information in this list. I'm going to go over that filter section later. Then you have all more technical stuff that I'm not going to go through at this moment. So, as I mentioned before, this is on the brackets here. This is a JSON formatted data, and as I mentioned before, we are using an hypermedia driven API. So, for example, we provide links on a page on a paginated collection. We provide links to, for example, to the next page of this one. We are on the first page, so we don't provide access to the previous one because there is none. So we provide access to the first page, for example, to the last page of this collection and to the next page. So this makes it really easy to navigate. And if we go to the end of it, and bear with me for a second, on the meta section of this one, you can get the pagination information, for example, how many pages do we have, how many elements on this list. So it's easier to figure out where I am in the collection. And the next thing to do is, now that we know how to navigate this one, we are going to look to one record of this list. For example, as I mentioned before, we are using the JSON API specification. So each one of the entries of this studies list is going to have the type studies. So for each element on a list of elements, you will know, you can check the type there and see what are you looking at. Then we provide a unique identifier. In this case, we are using MGnify accession numbers. It's MGYS, and then it's path with 0 and 5653. We also provide the ENA section number if you want to use it. That's ERP 124900. This was just one example. Then each one of the elements will have the type, the ID, as I mentioned before, and then you will have a list of attributes. In this case, we are looking at the status. For example, we have the bioproject section number. We also have, the center name. There's plenty of information there. And one of the things that I think I found really useful is in the relationship sections of the response, you will get links to each one of the related elements to this study, for example, to the geocoordinates, for example, or the samples, or the analysis, the biomes, and each one of those provides a link to it. For example, let's look at the samples. So now we clicked on one study samples relationship list. So we get all the samples for a given list, for a given study. We also provide the link. Everything is going to, as this is a collection, everything is provide the link section, and on the meta section, you will have the pagination information for it. And again, on this case, the type of data that you are getting there is samples, basically. And then you will have, it has the same structure, attributes with all the different values there. And then you will have also the relationship to this one. Let's go to the analysis, for example, for one study. So, as I mentioned before, on MGnify, we have one automated pipeline, and that pipeline is on the current version of that pipeline is B5, and we released one version on a regular basis. It would be one version per year, for example. So That could be that one study gets analyzed with an older version of the API, and then it gets reanalyzed with the latest version. So we end up having multiple analysis for the same samples. So, for example, if we have one study that has been analyzed with different versions of the pipeline, but we only care about the results for version, version 4.0, for example, we can go to the filter section on top of it on the web page and just click submit, and then we will get all the different studies, all the different analysis for that version of the pipeline. So, even though the API browser is useful, I wouldn't really recommend using this to get your data. So I'm going to start showing how you can actually interact with the API using Python. But it's really useful to have the API browser because basically you can test that basically your scripts are working as expected. So keep that in mind. Okay, so we are on my text editor. I'm going to show you some Python script how to interact with the API. And I'm going to provide the link to the repository of all of the examples I'm going to run, so you can then download those and run it by yourself. There's a README section on the root of the repo, so you can actually know how to install the different things and how to run it. But we are basically using Miniconda to install our dependencies, and the only dependency we have to get the data is the JSON API client. As I mentioned before, the JSON API specification is widely supported, so you get clients not just for Python. You have JSON API clients for R or for Go or Java. For JavaScript, you have clients for every major programming language, so that's really useful. But if you don't want to use the JSON API client, you can consume the API using the primitive, the HTTP primitive of the language. For example, if you use Python, you can use the URL module to actually to fetch things, because it's basically an HTTP REST API. So if you want to run this on your machine, please follow the instruction on the repo. So the first thing that you need, I'm going to go in increments. So I'm going to show you 3 examples. First, how to interact with one endpoint, and then how to with one endpoint that is going to fetch you just one sample, and then I'm going to see how to interact with a collection, and then how to interact with a collection and their relationships. So I'm going to build piece by piece. So the first thing that you need to do when you're writing a Python script using the JSON API client is to import the module, and we are going to use the session module to connect to the API. So basically, we define first the API endpoint. We're using this one, and then we just create a session using the with statement. And now that we have a connection to it, we can ask the session to get from the samples, results, and this ID, get me data from it. So you don't have to worry about anything related to HTTP. You just tell which result do you want to fetch, and the JSON API client is going to fetch that for you, and it will give you an object ready to use. So, for example, on this one, once that I get that sample, I can access the attribute directly. For example, the accession, the sample name, longitude, latitude, whatever I want. And you can also go through, for example, on this line over here, I'm going through the relationship runs, and I'm fetching each one of those runs. And a really cool thing about this library is that you don't have to worry about following the link and issuing a new HTTP request. That is actually done by the API, by the JSON API client for you. So it makes working with the JSON API really easily. So I'm going to run this one to see how this works. Am I in the correct place? Yes, I am. So to run the example, just write Python, and the example that I want to run, for example, JSON API. That's it. For example, we got for this sample SRS 2704733, we got the sample name, we have a bunch of different attributes, and we also go through the relationship. In this case, we are going to the biome and to the runs, and as you can see, I have the link to the runs here. So with a little bit with a small piece of code, you can actually start asking for things on the API and going through the relationships quite easily. So for the next example, I'm going to do something a little more complex. Same boilerplate with import. You have to import the library, define the API accession, the API base, and then as soon as you get that, for example, for this case, I'm going to fetch data, and I'm going to store the data from a collection from the API in a CSV file. So on this first line, I'm just opening the file, a CSV file, defining the columns on the CSV file, and then writing the header on the file using Python CSV module. And then, bear with me for a second, I'm using JSON API client to connect to the API, and then I'm going to use the filters capabilities of the API. On this case, I'm going to get all the samples. If you go on this line, you can see I'm going to get all the samples from aquatic environments that belong to the Arctic Ocean. Why Arctic Ocean? Because I'm filtering by latitude greater than 70. This is just an example, and this may not be completely 100% accurate, but I'm trying to show you the capabilities of filtering the data on the API using the metadata. So for example, I'm trying to get those Arctic samples from aquatic environment. So this is one of the other really useful things about the JSON API client, for example, that you can use the session.iterate, and this one is going to hide, and it's going to follow up all the different pages on this endpoint for you, so you don't have to be fetching the next link to get the next page of the link. So basically, it abstracts the API, and you can think of it as data, not as JSON that you need to, okay, I need to do the HTTP request. I'm getting the page, I'm getting the JSON. I have to check, oh, there is another link for me to get, or if there is another link to the next page, I need to go to the next page and run it again. This is all done for you if you use this session.iterate on an endpoint that returns a collection. And it will give you all the data, and it will hide all of that complex stuff for you. Then basically, I'm then just getting the information into the rows or the CSV files, all the different attributes that I want, and then I'm writing those down. I'm going to run this example now. Python example1.py. This should take a minute. Okay, it's done. It got from the API a total of 254 samples. So, and this was actually, it got me a CSV file that I'm going to just briefly explore using LibreOffice. So that's it. Using those few Python code, those few lines of Python code, you can get all the Arctic Ocean samples that we have on the API, and then you can format this as you want. Basically, we have the accession, then we have the sample name, the longitude, the latitude, the geographic location name, Arctic Ocean, so it makes sense. It's always important to check that after running an API call or whatever, that the results make sense. Then we have the biome and the study for the world of things. So this is really useful. Let me, for example, how we can add as many filters as we want. So for example, I'm going to read down this one, but I'm going just to focus on the study ERP 09703. This is the ocean sample study. So I'm going to filter this even further. And if we run it again, it should be faster. Oh, I made a silly mistake. I didn't save the file. So I need to run it again. Okay, with the new filter, it only got 3 samples. So we can explore it here. So now let's open it, LibreOffice again. So now we have only 3 samples there, and all of them have the OSD ocean sample day on the sample name, so it makes sense. So it's quite easy to add new filters to the Python code. Okay, how are we on time? Okay, so briefly, I'm going to show on this next step, I'm going to show you how you can actually build some kind of visualization with the data that you got from the API. So we are going to build a plot for the study MGYS 4274. This is from metabolically active microbial communities in marine sediments. And this study actually was trying to compare the taxonomical composition of archaea and bacteria on different samples. So we are going to try and see if we can plot that at the phylum level, if we can get the relative abundances of each one of the phylums there. I'm going to quickly go over this code, but you can, as I mentioned before, this is going to be available for you to download and run after the webinar. So basically, I'm creating a session to the API. I'm getting the resources, in this case, well, the analysis for that one. You can use this syntax also to get the analysis. Then I'm getting the taxonomic annotation of those analysis on this line over here. In this case, I'm going to focus on the small Robertson subunit. And I'm getting the phylum taxonomic rank. In this case, as I'm specifying this variable over here. And I'm getting that taxonomic annotations for those analyses. That's it. That's all the code that you need to actually get that information from the API. And then I'm doing some basically aggregating that and calculating the relative abundance for each one of the phylums. And I'm using the plotline library and pandas to transform the data and clean that data to actually then plot information. I'm not going to go through all this data wrangling. You can go later after the webinar, and you can contact me if you want, if you have any questions. So I'm going to just run it because we are running out of time. Python, this is example number 2.py. Those are warning messages from the plotline 9 library. You can ignore those. Then we got the plot. Sorry. So, for example, on this, we could easily build a relative abundance plot for all the analysis on a study. And as you can see, as I mentioned, this study was aiming to compare the bacterial and the archaea composition of different samples. As you can see, 3 of these samples of this analysis were aiming for the bacteria and 2 of them for archaea. As you can see on if you walk around the different bar charts, and you can see, you can explore this for your own. So I think that's mostly it. Some useful things for you to keep exploring this. First, we have, I would say, good documentation on the API, and not just the API, on the whole resource on this link, EMG docs and reader docs. If you go there, you will get the examples on how to use the API. Some of the things that I mentioned here are going to be already there. And also the code examples that I showed on this webinar are on this GitHub repository, EBI/metagenomic/examples. There are also R examples there for you to poke around. Please contact us if you have any questions, or if you want your data to be analyzed by us on the EBI/support/metagenomics. And please follow us on Twitter. Also, I would like to thank all the MGnify team that is basically supporting all this infrastructure and working with me to provide this really cool service. And the ENA team, we work quite closely with them. So I'm just trying to thank you to them and the funding agencies that provide the money for us to work on this really